Today we have to see two important theorems related to the moment of inertia to determine the moment of inertia of a given body about given any axis using the moment of inertia about the axis passing through center of mass. First theorem is principle of parallel axis and second is principle of perpendicular axis. Now out of these we have to discuss first a principle of perpendicular axis theorem. Of theorem of perpendicular axis is like this. See, the theorem states that the moment of inertia of plane lamina about an axis perpendicular to its plane is equal to sum of its moment of inertia about two mutually perpendicular axes concurrent with perpendicular axis and lying in a plane of the laminar body. That means according to this theorem, if this is the plane laminar body, one thing to remember about this theorem is that this theorem is applicable only for plane laminar body like piece of the plywood, notebook, etc., which has length and breadth, but its height or depth is very small, it can be negligible, hence it has only area. For such bodies we have to apply this theorem, that is theorem of perpendicular axis. Now let us consider this body of mass capital M, that this is the plane laminar body. Let us again consider point O through which a z axis is perpendicular to this plane. This is the z axis. And remaining two axes, that is x axis and y axis, are in plane of the body. If Iz is moment of inertia of the body about z axis. Similarly, Ix and Iy are moment of inertia of the body about x and y axis respectively. Then using the principle of perpendicular axis we can write this Iz equal to Ix plus Iy. This is we have to prove. Now see the proof. Consider a plane lamina of mass m. Ox and Oy, that is two mutually perpendicular axes in a plane of the lamina intersecting each other at point O. Let OZ be the axis perpendicular to plane lamina and passing through point O as shown in this figure. To prove this Iz equal to Ix plus Iy, let us consider a very small element of lamina of mass dm at a point P. That is, at point P, this mass dm is situated. For this, now join OP and draw perpendicular LP to the x-axis, that is this point is L, and L and ON perpendicular to y-axis. Then the distance OL equal to PN, which is equal to x, and distance PL equal to ON equal to Y. Now using these values, the moment of inertia of the element dm. See, the moment of inertia of the element dm about z axis equal to r square into dm, because the distance OP equal to r. OP equal to r. Hence, Iz equal to r square into dm. Similarly, moment of inertia of the small element dm about y square dm, because the distance of this point P from x-axis is equal to y, that is PL equal to y. Similarly, moment of inertia of the small element about y-axis equal to x square dm, because a distance of the small element dm from y-axis it is equal to x. Now the moment of inertia of total body can be determined by integrating this r square into dm. Similarly, we can write Ix equal to y square dm and Iy equal to integration of x square dm. Ix equal to integration of y square dm and Iy equal to integration of x square dm. Now see, from the figure, see, for the triangle OPL, see, for the triangle OPL, this is right angle triangle. Hence, we can apply the Pythagoras theorem for this triangle. We can write this r square equal to x square plus y square. Hence, the above equation becomes, see, Iz equal to integration of x square plus y square into dm. Hence, this is equal to x square dm plus integration of y square dm. Now see, x square dm is nothing but Iy and y square dm is nothing but Ix. Hence, we can write this Iz equal to Iy plus Ix. This is we are equal to Iy plus Ix. This is according to the principle of perpendicular axis. Okay. Now the second theorem is principle of parallel axis. See the statement. It states that the moment of inertia of body about any axis is equal to sum of moment of inertia about parallel axis passing through center of mass and product of its mass and square of perpendicular distance between these two axes. Now consider any body. Let C is the center of mass. Capital M is the total mass of the body. Let any point O, which is at a distance h from point C, and second axis which is parallel to this axis passing through the point O, like this. This axis is passing through point O. Now again let I c is moment of inertia of this body. I c is moment of inertia of this body about axis passing through center of mass C. And again IO is moment of inertia of body about axis passing through point O. That means if body rotates in this sense, IO is a moment of inertia about axis passing through point O. And if body is rotating about axis passing through center of mass, in this sense, the moment of inertia is IC. Now to prove this, let us consider a small element dm which is situated at point P. Now this point dm is at a distance r from O, and this dm is at a distance r0 from center of mass. That means here OP equal to R and CP equal to R0. Let us extend this line OC and draw the perpendicular from point P on this line. Let this point is point D. See the geometry of this figure. Now the moment of inertia of this body about axis passing through point O equal to IO, which is equal to integration of OP square dm, which is equal to R square dm. And moment of inertia of this body about axis passing through center of mass is equal to integration of Cp square dm, which is equal to R0 square into dm. Now we have to analyze the geometry of this body. Now see, from the figure, this OP square equal to OD square plus PD square. But this OD is nothing but OC plus CD. Hence we can write this OD equal to OC plus CD square plus PD square as it is. Which is equal to OC square plus twice OC into CD plus CD square plus PD square. Now see, this CD square plus PD square. See in the figure, this is the figure. CD square plus PD square, which is equal to R0 square, because this is the right angle triangle. Hence by applying the Pythagoras theorem, we can write this is equal to OC square plus twice OC into CD plus R0 square, because CD square plus PD square, which is equal to R0 square. Now multiplying both sides by dm and taking the integration, what happens? See, OP square into dm integration of this, which is equal to integration of OC square dm plus integration of twice OC into CD dm plus integration of r square dm. Now see here the integration of here integration, hence we can write integration of CD into dm is equal to 0. Now see the equation becomes integration of OP square dm, which is equal to integration of OC square dm plus 0 plus r square dm. Now see the distance OC is always constant, hence we can write OC square is constant, that is OC square integration of dm plus integration of r0 square into dm. Now this OC is nothing but h square, integration of dm is m, and integration of r0 square is ic. Now integration of this OP square dm is nothing but io. Hence we can write the equation like this: IO equal to mh square plus IC, that is IO equal to IC plus m into h square. This is according to principle of parallel axis theorem. This is the proof of perpendicular axis theorem. Okay.